I will introduce you very quickly. This is John Constable, coming to you live from the Sanger Institute. And he's going to give a talk entitled, I Upgraded iRODS and I Still Have All My Hair. There you go. We'll give you the full 20 minutes, and then we will have some lightning talks. Thank you, John.
Okay. Hello, Utrecht. So apologize, I couldn't be there in person, but hopefully you'll be able to make out some of what I'm saying. I can't see you guys at all, but what I could see before was a very dark lecture theatre with some people left at my laptop screen. So hopefully you can see something. Right, so...
you are very quiet. Can you get closer to the microphone, perhaps?
Okay, so let's find out. Is this any better, folks?
Maybe.
Can you hear me now?
That's a little better.
How about now? Any better now?
Yes, that's good. Thank you.
Okay, I shall project a little more. Okay, right, so I think we have questions at the end. Normally I'd say questions as we go through, but I think that's going to be a bit tricky. So if I can ask you to hold all questions till the end, that would be great. So, Wellcome Trust has been running iRODS for quite a while. We've about 6 years or so, and I've been involved in the last couple of years' work. Of our iRODS 331 setup, we have around, most of the zones are federated from one central zone, apart from one, because, you know, university and everybody's a bit different. Most of the hardware that we have on iRODS is physical, mostly for the storage of the data, but most of the ICAP servers are actually virtual machines running on our VMware infrastructure. We have two data centers, one local to us and another one about 50 miles up the road in another shared data center. And we have a 10 meg pipe between the two. This becomes important a little bit later on in the talk. So at the time we started, we were running iRODS 331. So I'm not going to be able to do this without questions, but nonetheless, how many people are still running iRODS 331? You can put your hands up if you are, and then can you tell me how many people have got their hands up? Because I can't actually see.
I don't see any.
Is anyone running 331 still? Okay. Has anyone heard of 321?
I don't see any hands. It's also very dark in here.
Okay. Is anyone still awake at the back there? Right. Okay. So we're running 331 on a bunch of tools before. We're using Oracle RAC as the database backend. We use a fairly simple setup. The whole aim with our iRODS 331 setup was to keep things as simple as possible, allowing us to recover data later on if there was any problems from disaster recovery point of view or something similar. And also from the idea that if we get a phone call at 2 o'clock in the morning, we don't want to be working with complex infrastructure to try and get things back into service again. So from people who are doing about 331, then we had the idea of resource groups. We had resource groups at the JSDC, the data center, and resource groups at Sanger. And those resource groups are basically split into available and full. And full resource groups are ones where the resources were actually, the disks were full. And we had scripts that moved from one to the other. So we wanted to move because, well, 331 had been end of life for a number of years at that point. There were new security fixes, that kind of a thing. We also were eyeing up the SSL encryption that came in 4, and we're looking at the composable resource trees as a way of taking out some of the rules that we had and having it far more of capability baked into iRODS. So again, so that we keep it as simple as in the iRODS configuration as possible. In the future, we're also looking to use the Gen2 query, which I believe Hal has literally just been talking about. Okay, so we had this in mind. We had a fair amount of user skepticism, should we say. People were happy with 331, and basically we had to make sure that forward X worked when we moved to it. But as well as that, it contained pretty much all of the crown jewels, which is what the picture is of, by the way, for people who don't know much about UK history. The crown jewels are held in the Tower of London, which is an odd place to be holding them because that's where they keep traitors before they were executed. But anyway, I digress. So we keep 14 petabytes worth of data, and it's, as I say, about 10 years worth of scientific research. And some of the problems with this is sometimes you can redo your research, but when it comes to genetic samples, sometimes you can't get the samples again. So the patient may have died, they may have moved away, may have lost contact, the program may have shut down. So we had to be pretty careful with it. We also had a placement student joining us that was keen to get started and working on some things with us, and I managed to grab his time first. He's no longer working with us, but that was because he was with us for a year, not because he left running in heart. So something we did found out as well is that when we started planning this, we started talking to NC quite a lot. We had a number of conference calls, we had a number of test plans going back and forth, and this was really, really, really valuable for our upgrade process. It was a big jump for us going 3.1 to 4.1 or something, and we wanted basically to make sure we got it right and to get the assistance that we can. So this is my first plug for becoming a consortium member if you're not already. And this is normally as well where I'd ask people to put their hands up if they're consortium members. But again, this might be a bit tricky to see, so if you're not a consortium member, when do you consider joining? Okay. So we wrote a test plan, a big Google Docs spreadsheet, and Google Docs was really helpful for us here. We could coordinate with quite a few of the other bioinformaticians, other team members, and also with volunteers themselves. We could share their list of things we were planning to do. They could communicate to us for what things were not going to work, whether or not we would have a approach that was flawed, and just generally comment on approach and things. So the basic plan that we came up with was to create a virtual environment running 3.3.1, to run our test framework to set things up, to upgrade to 4.1 point, whatever the version was at the time, and then to run the backspring framework again to verify that all the tests passed that I had before. And then if we found any problems, to keep doing this again. So overall, we divided the test plan into 3 sections because without this, we just have been, trying different things and seeing whether or not they worked. We wanted a fairly robust plan that said, first of all, things we absolutely must have. If we don't have this functionality, we can't do the upgrade. Version 4.x isn't ready for us. Come back later. Then there's things that we should have working. These are things that would make our lives easier, would make the users' lives easier, but we're not an absolute must. And then finally, there was the things that would be nice, but we weren't particularly wedded to. They didn't work. We could have addressed that later. So we started writing unit tests. We've actually put this up on GitHub. You can see the GitHub area there, WTSI-SSG, and the iRODS_testing repo. It's a bit out of date now, as you can see from the commit dates. It looks like we'll be revisiting it fairly soon because we're going to be looking at 4.2.1. And then we'll be looking to update these scripts with all the things that we found that we want to make sure work and continue to work, and all things that we want definitely to work when we do the upgrade. So for the unit tests, we chose the unit test framework called BATS. When I was writing this, I realized it could have been a pun on the iRODS name. Sadly, that wasn't why we selected it. We selected it because it was actually fairly simple to write and get going with. Mostly because everybody that was going to be working on this, everyone had different skill sets in development and programming languages. Nobody knew Ruby, everyone knew Bash, some people knew SHA-Unit, some people knew JUnit. It was all a bit of a mixed bag. So we ended up going with one that we could all agree on, or one that seemed fairly simple. So we also decided not to go for the more in-depth testing frameworks like ServerSpec and things like that, and try and keep things very simple, because again, the object wasn't to do a lot of testing, the object was to work out whether or not things had worked. And we found the URL I put there was a really good getting us going for using that. So this is an example of a BATS run for a small collection of tests running and the kind of output you can see there. It's quite helpful in this particular setup. You can integrate this into continuous integration because at the end of it, it'll come with a pass or fail kind of a test. Something that we found a little tricky was chaining a number of these together. We ended up writing tests for individual areas such as replication, for example, or checksuming, and we ended up running each of those individually. And I think in reflection, we probably would have been better off having one long set of tests, and at the end you'd have had 100 tests, 0 failures, or what have you. What you don't see as well there is that the tests are actually colour-coded, so the ones that pass are green, the ones that don't are red. Okay, so what we see here is a simple BATS test. It's just one test for the setup, and this allows us to do very simple things such as, as you can see here, create test files, including ones with Unicode in, set up test values, etc., and then do some moderately complex testing and report back. So having done all of this, what we found was that unit tests were great for unit tests, but in a shop result will surprise nobody who's tried to do functional and unit testing. Trying to make functional tests out of this was a lot harder. And we found that as we were writing our unit tests, quite often some of them would be better off for the functional test, and sometimes vice versa. So we might next time round be looking at using service spec to do the functional testing and unit tests for individual things. Something else we found is that we started to try and parallelize things by having one person writing tests for later functionality, whereas other people starting getting writing. And because we were fairly new to the whole Git flow work, this ended up causing problems because one person would start writing new test features while someone else was trying to do tests. So don't do that, boys and girls. Use something like branches, tagging, what have you. Idempotence as well. So people who know what idempotence is, that's basically doing the same thing over and over again and getting the same result. The idea with this is that we'd be able to run the unit tests a number of times and that we would get the same result each time. And sometimes this was actually quite hard because some of the unit tests would be initial setup and then there would be testing the functionality at the end of that. So running that multiple times was hard to implement. I'm not quite sure how we get around that other than possibly writing the test differently next time. But just writing them was something useful in and of itself. We learned a lot about how to interact with iRODS and how things were going just by writing the test and doing it. Next time round, so something we found difficult as well is that you can write a test that runs on one server, that's fine. But when you've got one iCat, two iRes, you find doing the orchestration between them, so run something on the iCat, set things up, then set things up on one iRes, set things up on another iRes. We ended up needing some kind of orchestration across this. Now, we're a couple of years down the road, in our infrastructure of code journey. So we'd probably be looking at something like Ansible or maybe Fabric, or even looking at what we can do within the service spec itself at this point. But at the time, that was something, it was still a fairly manual process. So the virtualized environment we used was using VirtualBox, and Andy Perry, who built a lot of this, did really good work here. Basically, the idea is that we had to have a vagrant environment running on our laptops that could run a version of Oracle in a VM, a version iCat in a VM, and two iRes in different VMs. So you basically have 4 virtual machines running, all that interoperate, and then you start running some tests. Now, this wasn't perfect. I think something we'll come on to later is that we could have done with some federation testing as part of this. But the idea of having something that we could just do vagrant up and spin up an entire set of infrastructure was enormously helpful. We could start with 331 and go from there. Something else we were doing as we were going through this is starting to use GitLab and continuous integration. And what we did with this was having packages built of the iCommands ourselves. Now, this is a slight diversion. The way we have used most of the packages, the way we did things in 331 is we used run in place. And what that meant was we would compile to a particular location and that we could then distribute this via NFS across our compute farm. This works very well for our compute farm and our users, where we could have versioned of the application, but works less so when in V4 the recommended way of doing things was using packages. So we ended up creating our own packages and doing this in the continuous integration kind of a manner. This is mostly okay, but we're actually now moving away from this to possibly being able to use Venture's own packages for this. So, yeah. So we also started writing the design documents. I don't know if people have heard the phrase, if you want to make God laugh, tell them your plans. Well, it's something like that. You write down everything that we want it to be to begin with, and then we see at the end how well we did. We also did some Gantt charts and timelines of what we think we were going to be doing, what and when. Partly this was because we needed to be able to communicate to the wider scientific community when their data would be offline, things like that, and partly it was so that we knew what we were doing. And this actually was very helpful because it allowed us to highlight holidays that we were having, holidays that the scientists that would be working with the data were having, and inavailability of data centers, all kinds of things around them. It's not very DevOps, you might say, where we're looking at this from a waterfall point of view, but actually, if you're following the agile model, you can use time boxes to have a very similar idea of it. And having this was really helpful in our communication with scientists and with the other implementation. Partly as well because it showed them, as things went on and things maybe didn't want to go entirely to plan, how much we were slipping and where things were. So we could say to people, we're supposed to be doing this zone next week, but that's going to slip till the following week or what have you. So we started testing on 417. We worked really closely with Renzi on this one. I said we were doing conference calls. We put a lot of issues in on GitHub, a long conversation on iRODS chat, and as I said here, 103 issues, that was in April. By the time we started doing migration in August, there was another 20 or 30 at least more. So again, if you're not a member of the consortium and aren't supporting Renzi in their efforts to do this kind of thing, I'd highly recommend being so. Partly because you get the kind of support that we've been very fortunate to have, and partly because it allows you to drive the kind of features you want to see. So what we found, now all the things I've got up here, these are things we found before we went live, before we did the upgrade. Some of these were complete showstoppers if we run into them in production. It was a massive win getting through all of these before we got there. So I might come back to this a little later as just people have got particular questions on things. But all of these we needed to work around for our deployment plan for when we actually managed to do the upgrade. It's things we need to communicate with our scientists for. For example, a number of our pipelines were still planning to use the v3 iCommand. And we needed to work out how that was going to work because we were only going to upgrade bits at a time as things went on. Then at the end of this, we came up with an upgrade plan. Now, the one we've got here, I'll be astonished if you can read it, but that was a year's work. I'm damned if I'm going to let it get away. You should be able to get the slides later and hopefully be able to read through this. This is a summarized version. The full details I've got, if people want the actual details of how we went through it, it's fairly focused on our deployment, notes on what we were doing, etc. But I'm very happy to share that with people who are interested. And my email's on the first of the slides, or contact me afterwards, and we can try and share things around. Okay, so we got this thing through. Everyone was signed off on the upgrade plan, and off we went with 418. So this is nearly a year after we started doing the testing. So quite a lot of work to get to this point. So we start off with the Federation Master. We have 5 zones, all reporting to one Federation Master, and by upgrading that first, we could allow the Federation to do the communication between the v3 iCommands that are connecting and the v3 zones that were behind that were yet to be upgraded. And that functionality was actually quite key to us being able to do a piece-by-piece upgrade of each zone at a time, rather than having to do a forklift upgrade of everything. But it wasn't without its issues, because almost immediately we found the things that we hadn't tested, as is often the way. And the area that we hadn't tested was Federation, the communication between the different federations. So, while we could, almost immediately we found we couldn't upload files of any particular size at all, and that listing files, or listing at all across federations was problematic. So we were able to pause that at that point until we could get some fixes from Etsy over what was going on. So we set through a number of debug versions, and one of the other showstoppers we found was that we couldn't upload large files. Now, large files is for us with about 2 gig and upwards. And of course, BAM files, people who know about bioinformatics, I think there's a number of you in there about BAM and CRAN files, are at least too big, if not much, much larger. So this completely stalled a number of our pipelines until we could work with Renzi to get around this. So this took about 3 weeks, and that was 3 weeks from we found we had a problem, we told Renzi, to having 419 out. So for anyone who's worked with any open source project, this is quite the turnaround. which we very much appreciate. Okay, so 4.9 is in production and working quite happily for a while. So we got to about November 2016, and we found that the resources we were putting in, the resources we had rather, that were part of the compound tree structure that we used, input files were still trying to be written in there, despite the fact that we had the high watermark functionality, which was supposed to stop them getting filled up. Now, this is something that we found, that we'd identified as part of our testing as something that we needed and meant to put in due to our feedback, I think. But it hadn't quite worked out the way everyone had intended. So again, much debug work and back and forth. It was changed to a minimum free space for bytes, create for bytes functionality, and we had a debug version of 4.1.10 in, and then shortly afterwards, when that was proved to be stable and working for us, 4.1.10 came out for everybody. And where that's working for us at the moment is we have a cron script running on every resource server that updates the free space and resource every 10 minutes. And then basically, every time the tree makes a decision over where it's going to put a file, it looks at how much space is left on the resource and how much space the minimum free space value is set to, and then it works out whether or not you can use that resource. So for all of that, of course, we then started doing some clear-up, and we're looking at the replication. So we used the compound tree for replication. We knew that there were a few files that were left over between the two when we did the migration. So we knew there was going to be a few that weren't fully replicated across within the zone, but across the tree. When we started looking, we found that it's quite hard to find the numbers that we needed, and that also, as this went on, we then had a congestion issue between our two data centers, which meant that the replication between one set of resources in one data center, one and the other, wasn't able to happen reliably. And that meant that we had quite the backlog, and turns out quite a number of areas that we need to catch up. And that was quite 3 months ago now, and as I speak now, we're about 15K files left to finish the replication. But that's probably another Silicon Tower. So overall, this cost us about a month of unavailability of iRODS to our scientific community, and every couple of weeks we would take iRODS offline as we did patch upgrades. The good news with this was that the packaged versions that we used were really easy to upgrade. You just did apt-get install, and off it went. And this was really reassuring, given that before, when we were doing upgrades on 3.2.1, we had to do a recompilation of the software, and we hoped it worked, or it didn't, but then rolling back, you still had a broken version of the software, and maybe you had to restore from a backup, or restore from a tar, or what have you. Whereas now, we knew we could roll back to the previous package version. So, I apologise for this slide. There's way too many words on it. Something that I wanted to put on the slide was this ugly bit of JSON at the bottom, so feeding the output of the iZone report in to the JQ program, which if you're dealing with any JSON, I would recommend you have a look at JQ if you haven't already. And what this is basically doing is filtering the output from iZone report and working out and showing you a resource server and the path on it. And we use this in a number of different ways for queries to work out, for example, when you're on a resource server, how many resources are on that resource server? Now, this might not sound an obvious question, but some of our resource servers have 20 resources on and some have 3. And you have to know which one it is, and then once you know each one, then we can use the naming convention that we came up with to fairly easily script bringing the resource up and down so that we can do maintenance of it. But overall, communicating with the scientists, communicating with Renzi, and just overall communication was utterly invaluable to doing all of this. We could have had people with pitchforks and the flaming torches at the door when all this was going on, because of the disruption that was going on, but we didn't, because people could see what was going on, and because we were keeping fairly regular communication. So we also had disk monitoring, lots of disk monitoring. This didn't entirely help me when I had some conference calls with OMC, so Charles, Jason, and others, very patient people. So also communication with people in general, I was chat mailing list, that's very helpful. test frameworks, unit frameworks. We use BATS, we have used Share Unit. Any of these kinds of things before an upgrade, after upgrade has been very helpful with knowing when things are working. So going on from here, we're looking to 4.1.11, and then from there we're looking to go to 4.2, 4.2.1, likely maybe 4.2.2, depending when we get there. But we've got a mandate from the business, as it were, to only take 2 weeks to do the testing this time, and the upgrade has to be smooth. So it's quite an upgrade for us. Once we've got all of that, we're also looking at SSL everywhere, using jQuery that Hal was talking about a minute ago, and maybe looking to move to the Ceph plugin to use the Ceph that we have in infrastructure that we're building in as part of our open stack. So that's it so far, and thank you to everybody in Medicine who's been assisting us over the past 18 months, 2 years, my colleagues at MPG and
Can you hear me? Thank you.
Get the video back. Hello.
Can you hear me?
I can.
All right, I think that means that the room is on. Are there any questions for Pete? No, that's not Pete. That's John. Sorry, I just saw Pete's name. Apologies. Questions? Oh, wait a minute. Wait for the, here you go. There you go.
Hey, how are you going to ensure this is only going to take 2 weeks?
That may or may not be, that may have been Jason.
How will you ensure the upgrade will only take 2 weeks to 4.2?
How are we going to ensure that the upgrade to 4.2 goes smoothly? We're going to do the same thing we did before, but quicker.
That sounds amazing.
The idea is that we're going to have we can hopefully get our OpenStack environment and be able to spin up a larger infrastructure and maybe look at what we've done, because we've got all the history of what we did before with the BATS tests, and maybe get a lot more BATS tests in to be able to run through a lot more of the coverage a lot quicker. But it's a challenge, and I'm not spending a lot.
Thank you.
Are there any other questions here? Oh. All right.
Sorry, can you repeat the question?
I think that's it, maybe? Well, thank you very much, John.
Okay, thank you.
Pleasure seeing you.